Okay, worksheet number 4. Question 1 to 2. Refer to solutions for which the pH is given below. You have pH equal to 1, pH between 2 and 6, pH equal to 7, pH between 8 and 12, and pH equal to 13. First, you have to remember the pH scale. It's between 0 and 14, and here 7, neutral. And in this direction, below than 7, acidity increases, and above 7, basicity increases. So here 14, the strongest base, and 0, the strongest acid. So now, question number 1, 0.1 molar acetic acid. Acetic acid is a weak acid. So pH for acids, A or B, below than 7. So not 1, because 1 strongest acid, so the answer is B. 0.1 molar ammonia. Ammonia is a weak base. Base above 7, so the answer D or E. E, 13, refers to the strongest base, so the answer is D. Now, question 3 to 4. Refer to the following aqueous solution. 1 molar barium chloride, 1 molar hydrochloric acid, 1 molar acetic acid, 1 molar sodium nitrate, and 1 molar potassium hydroxide is a basic solution. According to Arrhenius definition, basic contains hydroxide ion, so the answer is E. Has the lowest pH. Lowest pH, here the strongest acid. So B and C are acids. Acetic acid is a weak acid, and hydrochloric is a strong acid, so the answer is B. Now part B, CE questions. 1. The chloride ion concentration in 0.1 molar solution of hydrochloric is much less than 0.1 molar. It's a false statement. Why? Because hydrochloric acid is a strong acid, so it's completely dissociated to hydrogen ion and chloride ion. So if the concentration of 0.1 molar, the concentration of chloride also 0.1 molar. HCl is a weak acid. False, because HCl is a strong acid. Now statement number 2. Acid rain can lower the pH of lake water. It's a true statement. Why? Because acid rain contains acids, and as concentration of hydronium or hydrogen increases, pH decreases. The pH of water decreases as the hydronium ion concentration increases. It's a true statement. It's a CE question. Because when hydronium ion increases, pH decreases, and acid rain contains or increases the concentration of hydronium. Question 3. A 0.1 molar solution of hydrochloric acid has a greater concentration of hydronium than a 0.1 molar solution of acetic acid. It's a true statement, because HCl is a strong acid and it's completely dissociated, but acetic acid is a weak acid. So the concentration of hydronium in HCl greater than the concentration of hydronium in acetic acid. The chlorine atom is less electronegative than carbon atom is. It's a false statement, because chlorine atom has a higher electronegativity. 4. In 0.1 molar acetic acid, the concentration of hydrogen is smaller than the concentration in 0.1 molar hydrochloric acid. It's a true statement because acetic acid is a weak and hydrochloric acid is a strong acid. A molecule of acetic acid contains more hydrogen atoms than does of a molecule of chloride, hydrogen chloride. Yes, it's a true statement because acetic acid contains 4 hydrogen atoms, but hydrogen chloride contains 1 hydrogen atom. It's not a CE question because the concentration of hydrogen does not depend on the number of hydrogen atom in the molecule. Now part C, question 1. At 25 Celsius, an aqueous solution has a pH of 10. What is the hydrogen ion concentration? What is the relation between hydrogen ion concentration and the pH? Concentration of hydronium or hydrogen ion equal 1 times 10 to the power minus pH. So 1 times 10 to the minus pH equal 10 minus 10 molar. So the answer is D. Question 2. Given solution with the following pH values, which has the greatest concentration of hydrogen ion? As concentration of hydrogen ion increases, pH decreases. So solution with the lowest pH has a greatest concentration of hydronium. So the answer is 1. Now question 3. Which of the following solutions has the highest pH? Highest pH means the strongest base. So A, 0.1 molar ammonia. Ammonia is a weak base. B, 0.1 molar sodium hydroxide. It's a strong base. And C, D, E are acids. So the answer is B. Now question 4 to 5 refer to the solution prepared as follows. An acid is added to pure water until the hydrogen ion concentration equal to 1 times 10 to the power negative 4 and ionization constant of water equal to 1 times 10 to the power negative 14. So the hydroxide ion concentration in the solution. Okay. Ionization constant of water equal concentration of hydroxide times concentration of hydronium, which is equal 1 times 10 to the power minus 14 molar. So you have to calculate the concentration of hydroxide. The concentration of hydronium equal 1 times 10 to the power minus 4, all equal 1 times 10 to the power minus 14 over 1 times 10 to the power minus 4 over 1 times 10 to the power minus 4. So the concentration of hydroxide equal 1 times 10 to the power minus 10 molar. So the answer is C. Question 5. The pH of the solution is. What is the relation between pH and the concentration of hydronium? pH equal minus or negative the power. So negative the power equal 4. So the answer is B. Question 6. Correct statement about 0.1 molar solution of typical strong acid include which of the following? 1. It's a better conductor of electricity than water is. Yes, because acid dissociate to ions and ions increase the conductor of electricity. 2. It reacts with magnesium metal to produce hydrogen gas. Yes. 3. It has a pH greater than 8. False. Why? Because when pH above 7 refers to basic solution, not acidic solution. So the correct answers 1 and 2. So the answer is C. Now question number 7. The pH of 0.01 molar solution of potassium hydroxide. Potassium hydroxide contains hydroxide. So from this concentration you can calculate pOH, not pH. So the concentration of potassium hydroxide equals 0.01 molar, which is equal 1 times 10 to the power negative 2 molar. So the pOH equal 2. Now if you add pOH to pH, the total is 14. 2 plus pH equal 14, so pH equal 12. So the answer is E. Question 8. The molar concentration of hydrogen ion in a solution of pH equal to 6. Again, the relation between hydrogen and pH equal 1 times 10 to the power minus pH. So 1 times 10 to the power minus 6 molar. So the answer is B. Question 9. A solution that has a pH equal to 6. pH equal to 6, less than 7. Less than 7. So it's an acidic. At 6 here, so it's a weak acid. So the answer is slightly acidic. D. Question 10. A certain solution of hydrochloric acid has a pH equal to 3. Correct statements concerning this solution include which of the following? 1. It could be diluted to obtain solution of pH equal to 2. Diluted means decreasing the concentration of hydrogen ions. So what is the relation between concentration of hydrogen and pH? As concentration of hydrogen decreases, pH increases. So if you dilute this solution, pH must be more than 3, not less than 3. So it's a false statement. 2. The concentration of hydrogen ion equal 1 times 10 to the power negative 3. Correct statement. That the solution is more acidic than one that has a pH 4. Correct statement again, because as concentration of hydrogen increases, pH decreases, or as concentration of hydrogen ion decreases, pH increases. So the answer is 2 and 3. D. Question 11. The pH of 0.01 molar hydrochloric acid is closest to. Okay, what is the relation between pH and the concentration of hydrogen? 0.01 molar HCl equal 1 times 10 to the power negative 2 molar. So pH equal 2. The answer is D. 12. The hydroxide ion concentration of an aqueous solution of potassium hydroxide is 1 times 10 to the power negative 3. What is the hydrogen concentration? Okay, again. Ionization constant of water equal concentration of hydroxide times concentration of hydrogen, which is equal 1 times 10 to the power minus 14. The concentration of hydroxide equal 1 times 10 to the power minus 3 times concentration of hydrogen equal 1 times 10 to the power negative 14 over 1 times 10 to the power minus 3 over 1 times 10 to the power negative 3. So the concentration of hydronium equal 1 times 10 to the power negative 14 plus 3 negative 11. So the answer is D. Question 13. If a nitric acid solution has a nitrate ion concentration of 0.01 molar, the pH of the solution. To calculate pH, you have to get the concentration of hydrogen, and the question gives the concentration of nitrate group. So you have to write an equation. Nitric acid, when dissociate, it gives hydrogen ion plus nitrate ion. The mole ratio between hydrogen to nitrate equal 1 to 1. So the concentration of hydrogen equal concentration of nitrate, which is equal 0.01 molar, which is equal 1 times 10 to the power minus 2 molar. So pH equal 2. So the answer is B.